MenAppU presents Deriving the Unit Circle from Just 3 Points.
What's this all about?
Hey folks, welcome back. Today, I got an offer you can't refuse. I'm going to show you how to derive the entire unit circle from just 3 points. Look at this horrible thing. You're here because you probably have some teacher who's making you memorize this for a test or quiz, and you're freaking out. And I don't blame you. I would too. This is horrible. But I'm here to show you that with just 3 points, you can get this whole sucker. And all I'm asking in return is you like, you comment, you subscribe, whatever you can do to help support the channel. Now, I know what you're thinking, Buttercup. I don't have time to watch this whole long video. I get you. Come back. What I have for you down in the description, I have some chapter titles. I'm going to be doing some basic review. I'm not sure how much everybody knows about the coordinate plane, radians, all that. So you go down and you can go right to the 3 points if you want. I'm not going to know. Who's going to know? Do what you want and use this video. Let it help you out. But as the Australians say, let's crack on. Okay, by way of review, here we have our XY coordinate plane. If you're really hip, you're going to call it the Cartesian coordinate plane. Impress tons of people. But how does it work? On our horizontal axis, we have our X values. And on our vertical axis, we have our Y values. And if we move to the right, our numbers generally get larger. Our X values generally get larger. And if we move to the left, our X values are going to get smaller. If we go up, our Y values increase, and if we go down, our Y values will decrease. And how easy is that? Just like a game of battleships, we can plot particular points. Here we have the point X1, Y1, and we just give the coordinates, and there we go. We also take the coordinate plane and we divide it up into 4 quadrants. So beginning in the northern due east quadrant right here, we have quadrant 1. And then we move counterclockwise, we go to quadrant 2, quadrant 3, and quadrant 4. The big thing that I want you to remember for today, what's going to help with the unit circle later on, is where our X and Y coordinates are positive versus negative. So for example, X values, when we move to the right of the Y axis, so this way, all these X values are going to be positive. For the Y axis, or for Y values rather, all our values will be positive when we move up from the x-axis. So here's where we're going to get all our positive y values. And in terms of negative values, everything to the left of the y-axis will have negative x values. And everything below the x-axis will have negative y values. So just a reminder of how the coordinate system works and where those positive and negative values will occur for XY coordinates. Well, if you're new to the unit circle, at this point you're probably thinking, hey Bozo, what does the XY coordinate plane have to do with trig? What does it have to do with angles? What's going on here? Well, first, please don't call me Bozo. It's a little bit rude. I'm going to get over it. We'll move on. But to answer your question, we're going to graph our angles right now in the XY coordinate plane. We're going to start with this horizontal axis right here, due east. That is going to be 0 degrees. And as we move counterclockwise, we are going to graph positive angles in this coordinate plane. So you can see right here, this would be a positive angle, 40 degrees. The beginning ray, the starting ray, whatever you want to call it, is the x-axis, and the terminal ray is this yellow line that I've drawn showing where the angle ends. What's interesting about graphing in the XY coordinate plane, we can keep spinning around this over and over again. In fact, all the way around the coordinate plane right here is 360 degrees. And I can repeat angles. I can have angles that have the same terminal ray by completely spinning around the circle. So for example, 40 degrees, if I start and I come all the way around and I end up back here, I'm at my same ending position, but now that is an angle that we would say is 360 plus 40. That's going to be a 400 degree angle. It's going to end, it's going to have the same terminal ray as a 40 degree angle. And if I was to add another 360 degrees, because why the heck not, that would be 760 degrees. And I can keep repeating on and on and on forever. I can also go in the negative direction. So down below, you can see I wrote negative 50. When you move clockwise, you can create negative angles. So I can actually create, for example, this 40 degree angle again. If I was to start here at 0 and go all the way around and come back here, well, that's going to be negative 360 plus that 40 degrees that I didn't go. So we could also say that this angle is negative 320 degrees. And again, I can keep spinning. So this negative 50 degrees here, if I was to start and I went all the way around and back, we would say that another version of this would be negative 410 degrees if I did my math right. And we can keep spinning on and on and on. And that's going to be useful later if we get into sinusoidal functions. Not in this video, but that's where usually your pure calc class, your trig class is building up to. Oh, and I should mention before we move on, each of these quadrants is 90 degrees. So you can see, remember we started at 0. We went up to 90. We add another 90. We get to 180. We did a half turn. All right. We add another 90. We're at 270. And then we get all the way back to 360. So unfortunately, as confusing as all this unit circle stuff is going to be, we also now have to add an added wrinkle here. We're not going to just deal with degrees anymore. We're also going to use radians. And radians are just, if you think about it, everything we measure, and we usually have multiple ways of doing it. You got feet, you got meters, you got Celsius, you got Fahrenheit. So now we're going to throw in a new way to measure an angle. So here I have 30 degrees. And, you could call me up on the phone and say, hey, I got a 30-degree angle. I know exactly what you're talking about. I can pull out my protractor and draw it for you because I have no life. But you could also give me that measurement in radians. And a radian measure actually is how much of a particular circle, I'll give you a hint, it's what this video is on. Yes, that's right, the unit circle. How much of that circle is taken up by the particular angle we're interested in. So I can talk about 30 degrees from a protractor measuring little degree measurements, or I could talk to you about this little squiggle line I'm here creating, and that is a measure of an arc length. And that's another way we can record how big an angle is. So like I said, this is coming from the unit circle. Some people say I have a unibrow, uni meaning 1. So I want you to always remember the unit circle has a radius of 1. That's the key to all this. And what we want to do right now is we're going to do a double derive in here. We're going to derive what a radian is. Anyone know what this formula is? You should. This one's the circumference formula, all the way around the circle, that whole length, that one-dimensional measurement for a circle. It's kind of like perimeter. Well, in the special case of the unit circle, our circumference is going to be 2 pi times 1 because our radius is 1. So it simplifies down to just 2 pi. Well, congratulations, you just invented the radian. 360 degrees, we know, is all the way around the circle. So 360 degrees is the equivalent of 2 pi radians. Sometimes you'll see radians followed with the word radian. Usually you won't. So if you're questioning, is this angle measurement in degrees or radians? If there's no degree symbol, you're most likely in radians. Most radian angle measures are going to have a pi in them, but they don't have to. So keep in mind that pi is 3.14. 2 pi is about 6.28. If I tell you that an angle is 6 pi, is just 6 radians, you're pretty close to going around the circle, but not completely. But I don't have to actually have the pi in my answer. Let's talk about this conversion rate a little bit more because we can simplify it. So for example, let's divide both sides by 2, and we're going to get 180 degrees halfway across the circle is now just pi radians. And we can use that like we would in a chemistry or physics class to do angle conversion. So for example, 30 degrees. Remember, dimensional analysis, you want our units to fall out. So we're going to put 180 on the bottom. We got degree on top, degree on bottom. They will cancel. Is pi radians. 30 goes into 186 times, so we've just learned our first conversion here. Pi over 6 is the equivalent of 30 degrees. And we'll do a couple more conversions in a little bit. But that's your radian measure with the unit circle. Remember, unit circle, we call it uni because of 1. So hopefully at this point we're thoroughly bored. If not, I haven't been doing my job. But let's talk about how we can now take this unit circle and relate it to something we've learned a long time ago, hopefully. SOH CAH TOA, basic trig values. Here we have the circle drawn. Remember, it's got a radius of 1, and I put in an angle theta. Why theta? I don't know. We always use theta for angles. I don't know why. Doesn't matter. Leave me alone. Anyways, so we have our angle. It's drawn in, and we have an intersection point on the unit circle, and it's got coordinates x, comma, y. And what we want to remember about that is that we can draw a right triangle down, right? That's how we basically do trig, right triangles, right? We bring it down to the x-axis. And that right triangle is going to have two legs that are x and y respectively. Our x value from a coordinate is our length, our horizontal length of our triangle. And our y value from our coordinate is going to be the vertical length. Hopefully you guys can see that, of our right triangle. So we got a right triangle with angle theta. It's got legs x and y respectively. No matter how we draw this on the unit circle, we're always going to create this right triangle with the x-axis. And all of them will have a hypotenuse of 1, which is what makes this work. Let's go to trig for a minute. Let's go to sine. Remember sine, SOH CAH TOA up here, it says opposite over hypotenuse. Well, that means our opposite side is y, right? Here's our opposite side from the angle. And our hypotenuse, like we said a second ago, is always 1. We didn't say it, I said it, but you get the point. And that reduces down to sine is equal to y. That's the magic of the unit circle. When you have these points that you're going to be creating with angles, your y coordinate is nothing more than your sine value. All right, I'd say pretty cool, but it's not. Cosine, let's talk about that. We're going to have adjacent over hypotenuse. That's what SOH CAH TOA tells us. And our adjacent value is our adjacent touching the angle, right? That's our x. So that means adjacent is going to be x and hypotenuse is going to be 1. And cosine reduces down to just our x value. So our x values from now on and our points that we create on the unit circle with angles are going to be the cosine values. Let's talk about tangent for a minute. We're not going to do a ton with tangent today, but remember that tangent is opposite over adjacent. And we know that opposite is y and adjacent is x. So when we look at our points, if we ever want to derive tangent, all we got to do is throw y over x. This also gives us one of our first trig identities, though. Y, remember, is nothing more than sine. And x is nothing more than cosine. So this is an identity you'll probably need later in your class. But from now on, and we'll need it today a little bit. But from now on, tangent, you can think of as my sine of that particular angle over my cosine of that particular angle. And one more bonus identity. You can see up here I wrote 1 squared. Hopefully we all remember Pythagorean theorem, right? The square of the hypotenuse is equal to the sum of the squares of the two legs of a right triangle. Well, our legs are x and y respectively. 1 squared is just 1. And we said that x was cosine. And we always put the square right after the cosine because we don't want to get confused if we're squaring the angle or cosine itself. It's weird. I know. Just do it. Make your teacher happy. So we got cosine squared, sine squared. And this is Pythagorean theorem in trig. Another very good identity to kind of memorize and realize you can derive it just from the unit circle. Okay, so another point I really need to make before we can start deriving the whole unit circle from just 3 points is that circles are special because of symmetry. You draw any diagonal through it, and you're going to break that circle into 2 equal parts. So up here we have the point x comma y. That also means that that point, those coordinates, are going to repeat with a subtle variation 3 more times on our unit circle because of symmetry. Okay. Some of you may notice this little acronym I've written in here. I don't particularly like to use this, I'll be honest. I'll show you the way I do it in a minute. You can remember this acronym with the phrase, all students take calculus. We had in high school a different version for the C. I'll let you figure that one out. But that is supposed to help you figure out where our sine, cosine, and tangent values are positive and negative in our unit circle. All stands for all. The A stands for all, so all 3 trig values, sine, cosine, and tangent, are positive in the first quadrant. S means that in the second quadrant, only sine is going to be positive. In the third quadrant, only tangent will be positive, and then in the fourth quadrant, C, only cosine will be positive. I don't like doing that. Well, here's my way of memorizing this. You don't have to do it my way. But over here, let's remember that cosine is x, and sine is y, okay? So that means wherever x would be positive, cosine is going to be positive. And wherever y is going to be positive, sine will be positive. And remember, we learned that identity a moment ago, that tangent is sine divided by cosine. So remember your rules of multiplication. If you divide two positive numbers, you're positive. If you divide two negative numbers, you're positive. If you have any kind of mix, you're going to be negative. So in the very first quadrant, I remember that, hey, sine, I'm just going to call it S, is positive because my y values are positive. And cosine is going to be positive because my x values are positive. And tangent will be positive because a positive divided by a positive is still positive. In the second quadrant, now we remember that way back when we were talking about the xy coordinate plane, here's where our x values have become negative, but because we're above the x-axis, our y values are positive. So this point right here is going to be negative x, whatever the x was in our first point, comma y. So it's a same angle, reference angle. We're going to talk about that in the next slide. But that point that's symmetrical, it's reflected over the y-axis, has the same x and y quantity, except now x is negative. Okay? And that's going to be the key to deriving all these points and not have to memorizing them all. In quadrant 2, just a reminder, sine, we're still above the x-axis, we are positive. Cosine, we are now to the left of the y-axis, we're negative. And tangent is a blending of a positive and negative, so it is negative. Third quadrant, we're going to get our point again. Our x value is still negative. We've now moved below the x-axis, so that means our y values are negative. But otherwise, it's the exact same point. It's kind of been reflected over the origin. So this point right here, that's called our origin. That's where x is 0 and y is 0. Anyways, we're kind of reflected over that. In the third quadrant, remember that sine will be negative because we are below the x-axis. Cosine will be negative, and tangent will be positive because we're now taking a negative and we're dividing it by another negative, turning it positive. In the final quadrant, we've moved back over to the right of the y-axis, so our x value is going to be positive again. But our y is still negative because we're below that x-axis. So in quadrant 4, Roman numeral 4 here, we're going to see that cosine, well, let's start with sine. Sine's negative because we're below the x-axis. Cosine is positive, and tangent, again, is a blend, so it's going to be negative. So that's the way I prefer to memorize, where our values are positive and negative. But if you want to use all students take calculus, more power to you. Okay, final point before we actually start deriving the unit circle from just 3 points is reference angles. And this is what makes this work. That symmetry before and the fact that we can identify when one angle is related to another angle. You're going to see in a moment, just going to memorize those 3 points in the first quadrant. So here I've indicated an angle theta. It's actually 30 degrees. We did our conversion over before. That's the same as pi over 6. And we get our coordinates x comma y, and we know that this is a right triangle we've formed. And we need to be able to figure out, when do we get that pattern again? When are we going to get that repeat of the x and the y, except one might be negative and the other one might be positive and so forth? We need to do that with respect to reference angles. So this angle theta right here, we want it to repeat with the x-axis when we make our new angle. That's how we know we're going to get that same right triangle that's going to have the same 2 legs, the horizontal and the vertical. So if you're dealing with degrees and you're interested in knowing what this angle is in degrees right here from our x-axis to here, you can take 180 degrees all the way this way and then dial it back 30. So 180 minus 30, that's what I'm doing right up here. That angle that we're looking for that's going to have that same absolute value of x and y is going to be 150 degrees. We want to be able to do this with radians too. So remember, a half a circle is pi, and we want to dial back whatever 30 degrees is in radians. In this case, 30 degrees in radians is pi over 6. Got to do a little fraction work here. Pi is the same as 6 pi over 6, right? That's 1 times pi. So if I take 6 pi over 6 and I dial it back the equivalent of 30 degrees, which is pi over 6, that tells me that this angle over here that's 150 degrees is also 5 pi over 6. It's a little bit less than 1. Okay, this is how I'm deriving the same angles, the same angles that have the same reference angles in each of the quadrants, how we're getting the repeat of those x and y coordinates. Down below, what am I doing when I'm in the third quadrant? I'm taking 180 degrees or pi radians, and then I am adding my reference angle into it. I'm adding my 30 degrees or my pi over 6. So that's exactly what I've written right here. 180 degrees plus 30 degrees is going to be 210. So I know 210 is going to have a repeat of those values that I had in the first quadrant, except what's positive and negative is going to get mixed up a little bit. How do I do it with radians? So we know that halfway across the circle is pi radians, and I'm going to be adding a pi over 6. So I want to take pi and I want to give it same common denominator. So again, 6 pi over 6. I'm going to add a pi over 6 to that. I'm going to add that 30 degrees in. And that tells me, that this is going to be 7 pi over 6 radians. That's my equivalent angle. Okay, so third quadrant, I'm adding it to 180 or pi. In the second quadrant, I was removing it from 180 or pi. Fourth quadrant, when we go all the way around here to get my angle that's going to have similar x and y values, my reference angle again is that original theta, that 30 degrees or pi over 6. I'm going to do something a little different. This time, I'm going to go to 360 degrees or 2 pi. And I'm going to dial back a little bit, or I'm going to remove a little bit because we're not going all the way around the circle. So I think an example will explain what I'm trying to say here. I'm going to take 360 degrees and I'm going to remove that reference angle because I didn't get all the way around. I left that little theta over. So 360 minus 30 is 330 degrees. That angle is going to have a reference angle. That's the angle we form with the x-axis. That is 30 degrees. What do I do in radians? Down here, I'm going to take 2 pi and I'm going to remove my radian measure. So 2 pi is the equivalent of 12 pi over 6. You multiply it by 6 over 6 like we did before, and you get 12 pi over 6. So if I take 12 pi over 6 and I remove a pi over 6, that's the equivalent of 30 degrees, I know that this angle is 11 pi over 6 in radians. So at long last, we're going to take all that information we just learned. Sorry to make you sit through it. Those of you who skipped, you're probably the smart ones. We're going to take all that information about the unit circle, the symmetry, the repeating of values, the radian measures, how to divide, reference angles, all those things, and we're going to use these 3 specific points to derive everything our evil teacher is trying to make us memorize. 3 points to rule them all. And your teacher is not evil. I'm just kidding. It's his or her job to do this, so make sure we learn it, okay? We're going to start with the easiest points, in my opinion, to memorize. We're going to start with the first point that I want you to memorize, which is this sucker right here. Remember that we said this is called the unit circle. It's called the unit circle because it has a radius of 1. So this point is really easy to memorize. It's 0 degrees, it's 360, it's 0 radians, it's 2 pi radians, and infinitely we can keep spinning on and on. All we got to figure out is we've moved on the x-axis 1, and we've moved up from the x-axis, in the y direction, 0. So it's the point 1 comma 0. How easy is that? 0 degrees, 1 comma 0. Remember before we said that each quadrant is 90 degrees. So we're going to get our next point, 90 degrees. What's the radian equivalent? Well, you could do the fancy conversion, but remember halfway across the circle is pi radians. And if we split that in half, we're going to get pi over 2. So 90 degrees is the equivalent of pi over 2. And I know that my friends 1 and 0 are going to appear again because of that symmetry. I'm not rememorizing, just from the basics that this is going to have a 1 and 0. I know it's being derived from that first point that I circled down below. So I just got to figure out who's got the 1, who's got the 0, and who's positive and negative. In terms of x values, we have not ventured away from the y-axis. That means our x values are 0. And we've gone up, so our y value is positive. I got it. That's it. I don't have to derive that from scratch. I can do it based on that first point. I have that 1 comma 0 at 0 degrees. Let's continue on. Let's go another 90 degrees. That brings us to 180. And we already said half of a circle is pi, but realize that if you add pi over 2 to pi over 2, you also get pi. So we can keep adding these pi over 2s. 1 and 0 are going to show up again. I just need to figure out if anybody's positive and negative and who's who. Well, now we are on the x-axis again, and we have moved out in the left direction, which is negative by 1. So we know this is the point -1, 0. We're still on the x-axis. All y values are 0 on the x-axis. Nothing new here. I'm not using any brain power to memorize a new point. I'm purely deriving it from that original point. Let's add another 90 degrees, another pi over 2. So 90 degrees plus 180 is 270. And we're going to add a pi over 2 to pi. So let's do our fractions. Pi is the same as 2 pi over 2. Add a pi over 2, and you're going to get 3 pi over 2. And now I just got to figure out who's positive and negative and who's got the 1 and who's got the 0. Well, we are on the y-axis. When you're on the y-axis, x values are 0. We are down 1 from the origin, but we're down, so that means it's negative. So that means my sine value is -1 at that point. And that's a good point to remind, no pun intended there, that's a good point to remind you of before we continue on. The reason we're doing this is we are memorizing sine and cosine and potentially tangent values from the xy coordinates. So when I'm talking about this point right here, this one that we're memorizing, having coordinates 1, 0, what I'm really telling you is that cosine of 0 degrees or radians is 1, and sine of 0 degrees or radians is 0. Same with 360, 2 pi, and so forth. All right, I don't know if you can tell, but I'm losing a little bit of steam. I think I need a caffeine injection at this point. But let's move on to point 2. So remember, with point 1, we got 3 other points. We're up to the 4 out of the 16 we need to memorize. We're now going to go after 4 more points. And we're going to bring up our special right triangles from geometry. Why are they special? I don't know. No, but in this case, the 45, 45, the isosceles, it's half a square. Squares appear a lot in life, so I guess that makes it special. I don't know. Anyways, just a reminder, 45, 45, 90, and then we have these relationships between the sides. We have an x for the 2 legs, and then the hypotenuse is x root 2. Remember in this case that on our unit circle, our radius is 1. Our hypotenuse would be 1. But let's go ahead and figure out the sine and cosine, I should reverse that, cosine and sine values of 45 degrees from this triangle. So let's draw in our right triangle here. And let's do a little SOH CAH TOA with our isosceles right triangle. Let's talk about cosine, because that comes first. Cosine of 45 degrees. Well, if we use our generic right triangle, our 45, 45 isosceles right triangle right above, cosine is, from SOH CAH TOA, adjacent over hypotenuse. So our adjacent side was x, and our hypotenuse is x over root 2. You can see those x's, by rules of fractions, are going to cross out, and we're going to be left with 1 over root 2. Now, for whatever reason in polite math society, it's improper to have a radical in the denominator of a fraction. So we want to get rid of that root 2, make the queen happy, by doing root 2 over root 2. We're going to rationalize that fraction. I'm multiplying by 1, so I'm not changing its value, but I'm getting rid of the radical on the bottom. So this is going to become a root 2. Didn't plan properly. Root 2 over 2 is our cosine value for 45 degrees. So up above here, 45 degrees is the same as pi over 4 radians. You can use the conversion. You can do pi over 180 times 45. You'll see that you'll get pi over 4. But remember, a moment ago, we did 90 degrees was pi over 2, and if you take a half of that, you get pi over 4. So our cosine value is positive. We're in the first quadrant. And our sine value is going to be positive, and it's going to be exactly the same, because remember, this is an isosceles right triangle. That means the 2 legs are the same. That means when we do sine, we're going to do opposite over hypotenuse, and we're still going to be doing x over x root 2. So that means our sine, our y coordinate, also root 2 over 2. And remember, we have a special today. Whenever you buy 1 point, you're going to get 3 additional points for free. And I don't know why I only drew in 1 additional line here, but over here we're going to have our equivalent in the second quadrant. So that's going to be whatever our reference angle is going to be 45. So we're going to do that same little trick before. We're going to say we're going to take 180 and we are going to dial back 45 degrees. So 180 minus 45, I believe, is 135. And we can do it with radians too. Remember, we're going to be dialing back a pi over 4. So we're going to turn pi into a fraction with a 4 on top and 4 on the bottom. So 4 pi over 4 minus pi over 4 is going to give us 3 pi over 4. And these two angles will have reference angles with the x-axis that are 45 degrees, pi over 4 radians. Our xy coordinates are going to be the same, but remember, we're in the second quadrant. X is negative, so we're going to get negative root 2 over 2, comma, root 2 over 2. There's no memorization. You only have to memorize the point in this point right here in the first quadrant, okay? Let's go down to the third quadrant. Same trick as before. We're going to take 180 degrees and we're going to add 45 degrees to it. That's going to get us 225. We're going to take pi, which is 4 pi over 4, and we're going to add a pi over 4 to it. That's going to get us 5 pi over 4. And I am really running out of steam. But now we're going to have a negative root 2 over 2. And y values have gone negative because we are below the x-axis. I know people say don't go negative, but here we want to. So negative root 2 over 2. And we got a third point, and we haven't really had to memorize anything. And then for whatever reason, I drew this one in before. Same deal as before. Now we're going to take 360, and we're going to dial back 45 degrees. That means this angle is 315. All the way around the circle, 2 pi. 2 pi is the same as 8 pi over 4. We're going to dial it back a pi over 4. This is 7 pi over 4. And I like to put the little line in my 7. That's just what I do. All right, so here, x values are still positive. Remember, in the fourth quadrant, we're to the right of the y-axis. All students take calculus if you want. I don't care how you get there. Root 2 over 2. But we are below the x-axis, so y values, sine values are negative. And there we go. From 1 point, we're getting 3 others. We did that before on the previous slide. We're up to 8 out of our 16 points. Pretty good so far. All right, our last point, point 3. And you might be thinking at this point, it's only got me 4 each. You're supposed to be getting me up to 16. Well, there's no dirty tricks here. You're going to get actually 8 points from this one, okay? So don't worry about it. I'll show you. We're going to get there. All right, so here we have our second special right triangle. The 30, 60, 90. It is half of an equilateral triangle. So again, a very common triangle. And let's talk about sine and cosine. Okay, so let's start with 30 degrees. Let's do sine of 30 degrees. And remember, sine is opposite over hypotenuse. So that's going to reduce down to 1/2. That's nice and easy. So I'll give myself a little room here. And yeah, I did y first. Who cares? We're going to do cosine now. Relax. I'm just used to doing sine first. Let's talk about cosine. So cosine, and give ourselves some room here, of 30 degrees will be adjacent. So adjacent from the 30 is a side touching. Remember, opposite is across. So that means we're going to put a x root 3 on top. And that, again, is going to be over 2x. The x's cancel like they did up here. And we get root 3 over 2. Okay, so that means our cosine of 30 degrees is root 3 over 2. And I already derived way back on another slide that pi over 6 is the same as 30 degrees. All right, let's get that point, get our 3 additional points just from that we've been doing before. So we know we get 180. We're going to dial it back 30. That means this guy is 150. And pi, we're going to take pi and make it 6 pi over 6, and we're going to dial it back pi over 6. We did that before, 5 pi over 6. But the big takeaway is now we're going to have our x-coordinate, and it's going to be negative. It's going to be a root 3 over 2. And our y-coordinate is going to stay positive at 1/2. Okay? Down below, we're going to take 180, and we're going to add 30 to it. So that means this is going to be 210. And we're going to take our 6 pi over 6, add another pi over 6, and we're going to get 7 pi over 6. And that means our coordinates here, remember, we're in the third quadrant, x and y are negative, so we're going to have a negative root 3 over 2. Sorry if that's not legible. And a negative 1/2. Okay, and then finally in the fourth quadrant, really running out of room here, we're going to take 360 and we're going to dial it back 30, and we're going to say that this is 330 degrees. And we're going to take our 12 pi over 6 and we're going to remove a pi over 6, and that's going to tell us this is the equivalent of 11 pi over 6. And I'll have to sneak in the coordinates over here. It's going to be a root 3 over 2 comma negative, because we're below the x-axis 1/2. From one point we got the three others, but we're not done yet, because if we go down below we get this trig identity. These two trig identities, sine of theta equals cosine 90 minus theta, and cosine theta equals sine 90 minus theta. What this is basically saying is that if you have two complementary angles that add up to 90 degrees, the sine of that angle is going to equal the cosine of the complement, and let's get that from the triangle above. Sine of 30 would be opposite over hypotenuse. Cosine of 60 would be adjacent over hypotenuse. It's the same darn thing, all right? Sine and cosine just flipped places. So that identity allows us to get 4 additional points. Let's say up here, I'm going to have my 60 degrees. If you do your conversion into radians, 60 degrees is the same as pi over 3. Back in school, I would always get confused which one is pi over 6, which one is pi over 3. Remember, with a fraction, the larger your denominator, the smaller your fraction. So pi over 6 is 30, pi over 3 is 60. We already have these coordinates memorized. It is our 30-degree angle, but flipped. The x and y values flipped. Sine of 30 was 1/2. That means cosine of 60 is now 1/2. That also means that this sine value is the original cosine value of 30. It's root 3 over 3. These guys have just flipped on us. And we're going to do the same trick now. We're going to get the 3 additional points. So up here, we're going to have 180. We want to have a reference angle of 60. So we're going to take that 180 and we're going to dial it back 60. And that's going to tell us this is 120. Pi is the same as 3 pi over 3. We're going to dial back 120 degrees is 2 pi over 3. That means our x values are negative, because we're in the second quadrant, and our y values are positive, our sine values are positive. So there we go. We got our second point from that. Going down here, we have 180 degrees, and we're going to add 60 to it. That's going to get us up to 240. We had 3 pi over 3. We're adding a pi over 3, 4 pi over 3. I don't have these memorized. I'm literally just deriving them every time from those points in the first quadrant. And this one I'm getting double duty on. So we're going to have negative 1/2 again. And we're going to have negative root 3 over 2. I just have to figure out each time what's my new angle and where the positive and the negative values go. Down here, we'll have to do this one a little bit in the circle. So we're going to go 360 all the way around. We're going to dial it back 60. That's 300. 2 pi over 2 pi is the same as, as 6 pi over 3. So we're going to dial that back and we're going to get 5 pi over 3. I do this dialing back method. I know some of my students, they want to keep just adding 90 degrees every time. Whatever works for you. To me, this makes the most sense. It's the easiest thing to do. You don't have to do it my way. But hopefully you're getting something out of this video anyway. We are in the fourth quadrant. Our x value is positive, so we got our positive 1/2. But our y value is negative, so we have negative root 3 over 2. And from one point this time, from 30 degrees, pi over 6, we got an impressive 8 points. That brings us up to 16. We have derived the entire unit circle. Show that to your teacher. All right, one little bonus factoid for you before we get into some practice problems. Let's talk about our tangent values. So I don't have my tangent values memorized. Some people do that. So now you're going to be adding another 16 values that you have to memorize. Now you're up to 32. Ouch, I don't want to have to be memorizing that. Let's talk about if we have tangent of 5 pi over 3. How would we figure this out? Well, 5 pi over 3, what is our reference angle here? That would be like the 6 pi over 3, and we dialed it back. So we're talking about a reference angle here of pi over 3. Okay, that's what this angle is up here. Pi over 3, that's the 60-degree angle. Okay, so examining 60 degrees, hopefully we have that memorized now. Or maybe we have the 30-degree one memorized and sine value was 1/2, cosine was root 3 over 2. That means cosine here is 1/2. And the sine value is root 3 over 2. Which in the point we're actually looking for, our x value is positive 1/2. But because we're in the fourth quadrant, we're going to talk about negative root 3 over 2. Now, if you're taking a standardized test, if you're taking a multiple choice test, just knowing that our tangent now is going to be negative because we're going to take a positive and divide it by a negative or vice versa, that's very helpful. That might eliminate a couple answer choices that are positive. So that alone is some useful information. Let's remember our trig identity. Tangent is sine over cosine. Our sine was negative root 3 over 2, and our cosine was 1/2. The rules of fractions say take that first fraction and multiply it by the reciprocal of the second. 2's cross out. And we learned that tangent of 5 pi over 3, which should be 300 degrees, is negative root 3. So from those memorized points and this identity that tangent is sine over cosine, essentially y over x, we can now add tangent values to our list of derived values. All right, let's do some practice problems and put what we've learned into action. Here we have, what is the value of cosine of 4 pi over 3? So clearly we're in radians. I would suggest when you're doing these problems on tests, whatever, you always start by giving yourself a little unit circle. Look at that. Perfect. Okay, now what's the advantages of doing that? We can figure out what quadrants we're going to be in. We can figure out who's going to be positive and negative. We're going to make the teacher happy that we've done a little bit of work, right? And at the end of the day, if the problem is too hard, we can turn it into a frowny face and tell teacher this is too tough, okay? So all these benefits we have from drawing a little circle. But let's go back here. Let's draw our little unit circle to begin our problem. Roughly, okay. Where is 4 pi over 3 going to be? Well, 3 pi over 3, remember we said was pi. All right, that's half of the circle. So we've gone a little bit more than half the circle. What we've gone is we've gone into the third quadrant. So 4 pi over 3 is going to be roughly right here, okay? So at a minimum, I know now that my answer is going to be negative, and that might help me knock out a few answer choices. We want to think about that reference angle. What is that reference angle so we can get back into the comfort zone of the first quadrant and not have to have all these 16 points memorized? Well, our reference angle we form always with the x-axis, and remember that halfway around the circle, I said that a second ago, is 3 pi over 3. If you take 3 pi over 3 and remove it from 4 pi over 3, you get pi over 3. That's our reference angle. We can draw it in here. 4 pi over 3 was our equivalent of 60 degrees. So hopefully, we can go to the 30-degree one if we need to. But this is where we had the coordinates 1/2 root 3 over 2. Sorry, that went off the screen a little bit. But I have that one memorized because I just have memorized that sine of 30 is 1/2. That's the prettier one than the root 3 over 2. And then I derive everything else from memorizing that sine of 30 is 1/2. So that's the one coordinate I actually have memorized rather than that whole point. That tells us we're interested in cosine. That's our x value. So at the end of the day, our answer here is going to be negative 1/2. And we are done. But I highly, highly encourage, draw that little circle in. It's going to keep you honest. It's going to help you figure out what quadrant you're in. It's going to help you figure out what your reference angle you need. It's just a better visual, and it's going to kick in those 3 points when you need them. All right, here we have a slightly different problem. This time, if sine of theta is equal to negative root 2 over 2, that's been nice and cleaned up, and theta is between 0 and 2 pi, what are the possible values with an s for theta? And Sometimes you'll see this on standardized tests and in problems in school. Don't ignore that. That's important information. That's restricting it. This unit circle could go on spinning forever and ever and ever. And if you only gave values between 0 and 2 pi, 0 and 360 degrees, and the problem didn't limit it to that, you're going to get it wrong. So as before, what we're going to do is we're going to draw our unit circle. Perfect one to make into a front. Oh, that was horrible. Let me do that again. And I'm going to leave that in because no one's perfect, and you guys should realize people make mistakes, okay? So here we go. Here's our circle, and let's draw in our XY coordinate plane. And let's talk about, where is sine going to be negative? Sine is negative below the x-axis. So we know that our angles, should be in quadrant 3 and quadrant 4. We should have two angles because of that symmetry. We're going to get them again. All right, and specifically, hopefully we have memorized root 2 over 2. That's the isosceles. That's the 45. That's the pi over 4. So we're talking about this angle here and this angle here because we are restricted between 0 and 2 pi. Could be infinite answers if we weren't. That's 45 degrees. That's our reference angle right here. There's a 45. And right here, there's a 45. So let's derive it. I did radians here, so we should do our answer in radians, but I'm actually going to do all 4. Let's start with degrees. So let's say we have 180, and we add 45. That's going to give us this angle right here in degrees. That's 225. And then this one over here in the fourth quadrant, that's going to be 360 minus 45. So that's going to be 315. But those really aren't the answers I'm looking for. What I'm looking for is in radians because that's what I started with. So remember that halfway across the circle, that's pi. That's 4 pi over 4. We're adding a pi over 4. In the third quadrant, our angle that satisfies this condition where sine is negative root 2 over 2 would be 5 pi over 4. And in the fourth quadrant, we would go all the way around the circle. That's 2 pi. That's 8 pi over 4. And we're going to dial it back 45 degrees, which is pi over 4. We're talking 7 pi over 4. And there are our answers to practice problem number 2. Not all memorized, just using those 3 points. I'm specifically, in this instance, really using pi over 4, having the points root 2 over 2, comma, root 2 over 2. And I kind of talked it out rather than showed it, but you guys get the point. And finally, we get to practice problem number 3. What is the value of tangent of 5 pi over 6? So as always, we start with our frowny face. To keep us honest, we put in our coordinate plane. And we do this really quick. We don't kind of obsess like I'm doing right now. And we think about, where is 5 pi over 6? Okay, so 6 pi over 6 would be halfway around the circle. That's pi. We know that we're missing a pi over 6 to get all the way to pi. Pi over 6 we learned before was 30 degrees. We're in the second quadrant. Our reference angle is 30 degrees, pi over 6. Tangent is going to be negative there because our x values are going to be positive. And our y values are going to be, our x values are going to be negative and our y values are going to be positive. Our reference angle is pi over 6. So let's start with that one. So here's our pi over 6. And that was horribly drawn, but hopefully you get the idea. And remember, this is the 30 degrees. This is the one that I really just start by saying, okay, sine's 1/2. And if sine's 1/2, then the other one has to be root 3 over 2. Okay, so what would tangent? Remember, tangent is sine over cosine. And in this case, sine is 1/2. And cosine is going to be negative root 3 over 2. Because we are in the second quadrant for this particular problem. Okay, so we're going to have a negative root 3 over 2. So our rules of fractions, we're going to have 1/2 times the reciprocal, so 2 root 3. Our 2's cross out. We're left with negative 1 over root 3. But it is improper to have that radical on the bottom. So we need to multiply by root 3 over root 3. That's 1. And that will allow us to have a 3 on the bottom and a radical 3 on top. Because when you do a radical times itself, a square root by itself, the square root symbol just goes away. So we're going to get negative root 3 over 3. And that is our answer. We are done. All right. Bottom lines. What did we learn today? We only need 3 points. This guy right here. This guy approximately right here. And this guy right about here. So 0 degrees. 30 degrees, and 45 degrees. We only need those 3 points to memorize the entire unit circle. We can do so because of reference angles and symmetry. That's what makes that all possible. And finally, if we want, we can then further derive the tangent values from those 3. That's all I got for today, but before I let you go,
All right, Buttercup.
let's tell the folks how they can help grow the channel. Please like, subscribe, comment about future content you'd like to see and how I can improve these videos, tell your classmates, and consider joining the flock on Patreon for extra practice problems and videos with tips for taking standardized tests. Please see the description below for details.